Okay, we're going to talk a little bit more about areas, and we're going to look at the areas of some slightly different shapes that we have not yet talked about. So, the area addition postulate says that the area of a region is the sum of the areas of its non-overlapping parts, which means if you cut it up into smaller pieces and add up all of those areas, you get the area of the entire figure, which makes perfect sense. It's not rocket science. So in the figures below, a right triangle is cut off from one side of a parallelogram and translated to the other side as shown to form a rectangle with the same base and the same height. So you'll notice we have a parallelogram, right? Remember, parallelograms have two pairs of opposite, parallel, and congruent sides. If I cut a little triangle off of this, making these right angles, and I slide it over here, I cut a small piece off of the base, but I'm sticking it together on the other side of the base, and I'm connecting it over here, we end up with a rectangle. So hopefully you could think about how to find the area of this shape based on these two measurements. And then you would also be able to work backwards and say, well, hey, that area is going to have to be the same as this area. So the area of a rectangle is base times height. The area of a parallelogram is also base times height, because we can always cut off one of these triangles and slide it over here instead to form a rectangle. Now it's important to notice that the height is the perpendicular distance between bases, not the slanted side of the parallelogram. It's really important to remember that the height is the perpendicular distance between the bases, not the slant height, which would be the length of this side. It is not, that's not the one we're talking about. Okay, so the area of a parallelogram is A equals base times height. So let's find the perimeter and the area of parallelogram ABCD. So the area is base times height. So the area is going to have to be the base, or 10, times the height, which would be 5, not 4. Okay. Now, 4 could be considered the base also, but if we were going to use that, I would have to know this height, which we don't know. So we can't use that as the base. So 10 has to be the base, 5 has to be the height. So the area is going to be 50 inches squared. The perimeter is just the distance around, right? So I have a 10 over here, which means I have 10 over there, because the opposite sides of a parallelogram are always congruent. So that would be 20. And then I have 4 down here, which means I have 4 up there also. Or you could think about it as 2 times the base plus the slant height, if you will, or the other side. So the perimeter is going to be 2 times 10 plus 4, 2 times 14. Perimeter is going to be 28 inches. Perimeter is not squared, right? The units are not squared because we're just walking in a distance. It's a length. Area is a two-dimensional measurement. Okay, here's 2 more for you to do. I want you to pause the video and tackle these. You might need to use a couple of other techniques to find some missing values, but if you work on it for 2 minutes, I would imagine you'll be able to figure it out. So pause the video and come back in 2 minutes. Okay, so I want perimeter and area. For the perimeter, this base is 21, which means this one's also 21. It's going to be 2 times 21 plus 17. So 2 times 38, which is going to be 76 centimeters. The area is the base times the height. So the base is 21. This is the height, and I don't know what that is. However, this is a right triangle. So if I do x squared plus 8 squared, that has to equal 17 squared. So x is the square root of 17 squared minus 8 squared. It's definitely a calculator question, so I'm going to go square root of 17 squared minus 8 squared. Make sure all of that is inside the parentheses of the square root, and you end up with 15. So the base is 21 times 15, which makes our area 315 centimeters squared. Perimeter 76, area 315. Now in this one, perimeter area. Let's start with the area on this one. Here's the base, 23 feet. I don't need this because that's not actually part of the base, right? So 23 times the height, which is 24. Now, nothing says that the perpendicular distance between the sides has to be inside the shape. If I scoot it over here, that will still be 24 feet, won't it? It's the same distance. So I take 23 times 24, and we're going to end up with 552 feet squared. Now the perimeter, 23 times 2, but I don't know this side length over here, right? Again, it's a right triangle though, so if I do 24 squared plus 7 squared, that should be L squared. So the square root of that would just be L. So I'm going to do the square root of 24 squared plus 7 squared. I'm looking for the hypotenuse this time, so I don't need to subtract. And this L will be 25. So I'm going to do 2 times 23 plus 25. 23 plus 25 is 48 times 2 is 96 feet. Again, perimeter is not squared, it's a length. Okay, we've got another one here. This one's a little bit different. I have the base and the side, but I need this piece right here. The difference is, in the past, we've been given this length also, and we weren't. We were, however, told that this is a 45-degree angle, which means, if you think about it, this also has to be a 45-degree angle because this one has to be 90. That means that these two sides are the same length. So if I do h squared plus another h squared, that should equal 8.5 squared. So 2h squared, if I take the square root of that, I get 8.5, right? So rather than take the square root of that, though, 2h squared equals 8.5 squared, I'm going to divide both sides by 2. So let's go 8.5 squared. That's 72.25. And divide that by 2. Then I'm going to take the square root of that whole thing to get h by itself. So I'm going to take 72.25 divided by 2, and I'm going to take the square root of that value, and we are going to end up with an h of 6.01 millimeters. So the area, base times height, base is 15 times 6.01 for the height. We should get an area of 90.16 millimeters squared. Depending on how you round, yours might be slightly different, but that should be pretty close to the 90.16. Like the base of a parallelogram, the base of a triangle can be any one of its sides. The height of the triangle is the length of an altitude drawn to a given base. That altitude is that perpendicular distance we talked about before. An important thing to note, the area congruence postulate, if two figures are congruent, then they must have the same area. So if two figures are the same, their areas will also be the same. Okay. So let's look at this parallelogram. Again, if we cut it in half, but in this time we cut it along a diagonal, you'll see that we form two congruent triangles with the same base and the same height. Since those triangles have the same base and the same height, we also know that their areas must be the same. So if I cut this entire piece basically in half, right, I should get two pieces that are each half of that. So if the area of a parallelogram is base times height, and I cut it in the half, we get the area of a triangle. And that's where the formula for the area of a triangle comes from. It's just half of a parallelogram. It's also half of a rectangle. You can make two triangles by dividing a rectangle in half diagonally as well. So area is 1/2 times base times height, or 1/2, or base times height divided by 2. Whichever way you prefer to think about that. You can pause if you need to keep looking. I'm going to move on. So DeAndre needs enough mulch to cover the triangular garden shown and enough paving stones to border it. This is actually something I've been doing recently. I've been putting pavers around my patio and putting mulch down in all my flower beds. And this is actually something I've done, is gone around and measured my flower beds, because mulch is, it's not expensive, it's not free. So you certainly don't want to order more than you need. If one bag of mulch covers 12 square feet, let's mark that. One bag of mulch covers 12 square feet, and then in a different color, one paving stone will give you a 4-inch border, meaning 4 inches long, not 4 inches wide. How many bags of mulch and how many stones does he need to buy? Well, if you think about it, the blue is how much area, right? It's in square feet. So that's area that we need to find. The length going around the edge is perimeter. So we need to find those two things for this triangle. Let's start with the area. So area is 1/2 base times height. We're going to keep the 1/2. I need a base. Well, the base could be 7 feet. Then I need a height. The height has to be perpendicular to the opposite corner, which means we have to come outside the triangle to get it. This is the height of the triangle. Perpendicular, meaning this right angle, from the base to the opposite vertex. Sometimes that'll be inside the triangle, sometimes it won't be. So 1/2 of 7 times 9. Well, 7 times 9 is 63, so we divide that in half and we get 31.5. 31.5, it's in feet, so that's going to be feet squared. If one bag of mulch covers 12, how many do we need? Well, if you do the 31.5 divided by 12, you'll see that you need 2.625 bags of mulch. I don't know if any of you have gone to Home Depot to try to buy 0.625 bags of mulch, but they're not going to like that. So if we need 2.6 bags, we're going to need 3 bags, and you'll have a little bit left over. Now let's look at the perimeter. We want to know how many pavers. So the distance around is going to be 7 plus 23 plus 15. Right? Not rocket science. 7 and 23 is 30 plus 15. That's a 45-foot perimeter. But each stone provides a 4-inch border. So if you think about that, 4 inches is 1/3 of a foot. We would need 3 4-inch pavers to get a foot. So if I need 3 per foot, I multiply that by 3 pavers per foot, and I am going to need 135 pavers. The height of a triangle is 5 centimeters more than its base. The area is 52 square centimeters. Find the height and the base of this triangle. Whenever you're faced with a problem even remotely like this, where you're relating different pieces to each other, the absolute best thing to do first is to draw a picture. So I want you to take 30 seconds, just hit spacebar, hit pause real fast, and try and draw this picture, and try and label as much as you can based on the information. Okay, hopefully you have a picture, and hopefully it looks something like this. I have a base. It's b centimeters. I don't know how long that is, and I don't know what the height is, but I know that it's 5 centimeters more than whatever the base was. I know that the area, which is 1/2 base times height, is 52. So that means that the base being b and the height being b plus 5 could be plugged in for h. This equation I can solve. It only has one variable in it, so let's start working. 52 equals 1/2 b squared plus 5b, right? So if I multiply both sides by 2, I'll get rid of this 1/2. So let's multiply both sides by 2. Whoopsies. So 2 times 52 is 104. Half times 2 is gone. I have b squared plus 5b. So 0 equals b squared plus 5b minus 104. I could try and factor that, but coming up with factors of 104 isn't super easy. So you could use the quadratic formula. Let's try to factor it real quick. 104. I've got 1 and 104. 2 and 52. 3 is not going to go in. 4 and 26. 5 is not going to work. 104 divided by 6 gives us 17.3. 104 divided by 7, nope. 8 is going to give us 13. Well, wait a second. If I subtract 8 from 13, I'm going to get 5. So this could be written as b and b plus 13 minus 5. So that's equal to 0, right? So b is either a negative 13 or a positive 5. Now when you think about what b is the length of this side. You can't have a negative length, right? That's an extraneous solution. It's extra. But b equals 5 will work. So if base is 5 and the height is 5 plus 5 more, that means the height has to be 10. What we've essentially just done is create a system of equations. We had one equation where 52 equals 1/2 b times b plus 5. And the other equation was much simpler, where the height was equal to the base plus 5, right? This equation actually would be h. I had already done the substitution. base times height, right? Then I substitute this value in for h, and that gave us an equation we could solve, which told us that b was 5. Plugged that b back in there and solved for h as well. So even though you may not have realized it at the time, we were just solving a system of equations. Best of luck with the homework and have a great day. Reach out to me if you have any questions.